This is the third homework question. It says, use the experimental data below to determine the rate equation for the following reaction. And it says 3A plus B goes to products. And it doesn't matter what the products are because we're studying the kinetics of just the reaction, the forward reaction. And I would suggest that you start by writing out the general form of the rate law. Which is another way of saying the rate equation. And the general form says rate equals lowercase k, which is our rate constant, times concentration of the first reactant raised to some exponent that may or may not be 3 times the concentration of the other reactant raised to some exponent. And you can use a or b here, you can use x and y, it doesn't matter. If there was a catalyst, the catalyst would appear over the arrow and the catalyst would also show up in the rate law, but there's no catalyst listed for this one. Now, the heart of this problem is we need to find A and B. In order to do this, we need to look at our method of initial rates data table here. And what you're looking for is you're looking for when one of the reactants has no change in concentration, and that would be between experiments 1 and 2, while the other one does have a change in concentration, because then this change in concentration is the only thing affecting the initial rate. So, and in the lecture outlines, we covered 2 different ways to do this. First, you actually plug everything in and do the natural logarithms. And I always try that, or I always save that for my second approach. What I'm going to do is I'm going to look at experiments 1 and 2. And what I can see is that from experiment 1 to 2, the concentration of B has increased by a factor of 3. So 0.6 divided by 0.2 is 3. And B has the exponent little b here, so I'm going to put b. And then I'm going to find the ratio here, 1.305 divided by 0.145. And I can see that this ratio, 1.305 divided by 0.145 equals 9. So one of them, the concentration changes by a factor of 3, and the rate changes by a factor of 9. This becomes an equation for me, so 3 to the b equals 9, which means that b must equal 2. And that's a B, not a 6, so let me be clear about that. That's a B. I don't know if that helps. Okay. Now let's try the next one. So I'll do this in another color. So from 1 to 3, the concentration of B is constant, but the concentration of A changes by a factor of 3. So 3 to whatever the exponent on the concentration of A is equals, and now I have to figure out the ratio 0.435 divided by 0.145. And that equals 3. So 3 to the A equals 3. A must equal 1. So now my rate law becomes rate equals K times concentration of A to the first power, so I don't have to write it, concentration of B to the second power, because little b is 2. And it looks like that's this one here. And I did give you plenty of options for this one, and different ones have different answers in this pool. And this is what's called the rate law, and we've just determined it in terms of the exponents. Okay. Any questions about this? Okay. Well, let's see. Yeah, I think that's a good way to do this.